Hello, welcome back to another chapter of Death by Kinematics. Let's see if we can get through a few more problems. It's football today, and they say a punter on a football team kicks the ball straight up because of a rush. The ball starts. Okay, let's take a moment to appreciate that they somehow got their foot onto the ball while it was 2 meters in the air. That's not normal in any way. But anyway, if this is the ground, our ball started a little bit off the ground and it's going to fly up into the air and then it's going to fall back down and it's going to go thump. And they tell us it began 2 meters off the ground and its initial velocity was 32 meters per second. And they want the maximum height up here. What do we know about that point? Remember, when something's rising, it's going to have positive velocity all through here. Then it tops out. When it's falling, it has negative velocity. Right here at the top, when it hangs still in the air for just an instant, its velocity is 0. So we can say the ball ended up with a 0 velocity at that point. And because most football teams are on Earth, we can assume our acceleration is minus 9.81 meters per second squared. So if only we had a formula that we were kind of familiar with that worked with VF and VI and A. Are you starting to believe that this is a great formula yet? Let's see, our final velocity is 0. Our VI is 32. Don't forget to square it. Plus 2. Now, acceleration is negative 9.81 because it's oriented down. Gravity pulls downward. And then we have a d that we don't know. 0 squared is 0. 32 squared is 1,024 minus 19.62d. I've written 2g enough times that I kind of know what it is by now. Take the 1962 to the other side, and the d, of course, equals 1,024 and 1,024 divided by 19.62. I get 52.2 meters. Now that is not the final answer. Do you see why? This 52.2 meters is how far we've gone since our starting point, but our starting point was 2 meters off the ground. So our actual final height is going to be the 2 meters we started at plus another 52.2 meters, grand total of 54.2 meters. Be careful if your starting point is not right on the ground. It's easy to forget about that extra bit of distance, and in this case, it isn't all that much, but it certainly does affect the answer. And look at that. They have the 52.2 among the choices ready to snare people, and here's the correct one. Okay, what else they got? Rider in a hot air balloon drops a coin from a height of 610 meters. Okay, so way up here is a balloon. A coin is tossed out and it falls a long way down. Hits the ground there. Now, over 610 meters, the air resistance would be pretty substantial, so neglecting air resistance is a little sketchy here, but that's all right. We'll get to air resistance later. Our distance is, it's not 610. Do you see why? It's minus 610 because we started high and fell 610 meters. Our height went down. Anytime you're moving down like that, you should be getting negative displacements here. So minus 610, falling objects get minus 9.81 for their acceleration. The word drop means to hold something still and then release it. So our initial velocity is 0. If there's a positive or a negative velocity, then they should be using a word like throw or toss. And then they should give us some information about what that initial velocity was. But the word drop means we're justified in doing this. And they want final velocity. So there are other formulae in physics, I promise, but this one is just super good and we end up using it a lot. Final velocity is what we're trying to find. Initial velocity is 0 squared, not that it's going to matter. plus 2 times acceleration is negative because gravity pulls down. Displacement is negative because the coin fell down or displaced down. 0 squared is 0, so that's useless. 2 times 9.81 times 610. I know the negatives will cancel out, so I just didn't bother putting them in the calculator. Vf squared is 11,968.2. Now, that number has two square roots. Oops, sorry. This number has two square roots, and they are positive 109.4 or negative 109.4. Technically, every number except 0 has two different square roots, a positive version and a negative version. And writing a plus or minus like this means that you're recognizing both answers. Which one do you think makes sense for a coin right here? A positive final velocity would mean the coin's rocketing upwards at 109 meters per second. That doesn't seem right. And the negative velocity would mean the coin's plummeting towards the ground, downward, and it's going to hit the ground. So negative 109 is the one I would pick. The math offers you two answers, and you have to discern that in this case it's the negative answer that makes sense. Now, they gave this with 3 digits, so really 109.4 is not appropriate, and we should just say minus 109 meters per second. For the direction, I gave it with a negative sign to indicate it's falling or moving downward. Up here, they just write the English word down, which is also a lovely way to give it. So do something to indicate the direction. You can give the sign if you want, or you can write some words. Generally, both are okay. Let's see if we can get one more in here. Okay, moving object and a graph. So what we have here is an object that at time 0, when they started the clock, it wasn't moving. Its speed was 0. And then its speed went 5, 10, 15, 20. It was gaining 5 meters per second every second. I don't know if we need that for this one, but when your acceleration keeps going up by 5s every second, that means your acceleration is 5 meters per second squared. Acceleration is every second how much is your speed increasing, or if it's negative, decreasing. So we have the acceleration. What else have they given us? At the beginning, we can see that our speed or our velocity was 0. So I can say initial velocity was 0. They're asking about the first 4 seconds of travel. So although they gave us this graph that goes up to 5, they really want us to stop here at 4 seconds. And at 4 seconds, our velocity was 20 meters per second. And the elapsed time was 4 seconds. And they want a distance. Guess what? This could do it. But I've been using this so much, I'm going to try to do this problem a different way just to give you a little variety. That would work fine. You'd get 20 squared equals 0 squared plus 2 times 5 times some unknown distance, and you could work out the distance. Or, just for the sake of being a bit different, we have a formula that says distance equals VIT plus 1/2 AT squared, which should do the job here. Our total distance is going to be, well, the initial velocity is 0, so we get 0 times 4 seconds plus 1/2. Acceleration is 5, and t is 4, and don't forget to square it. 0 times 4 is 0. Following bad math, I have to do the exponent first. 4 squared is 16. 16 times 5 is 80. Half of that is 40. So our overall distance is 0 plus 40, which is 40 meters. One more. Let's see how obnoxious the next one is. Well, it's a little too big. We'll fix that first of all. Okay, we're dropping coins again. This might be the same as that balloon problem, so maybe we can do this kind of fast. The CN Tower in Toronto is big thing like that, big radio antenna on top. And they say at 0.553 kilometers, a kilometer is 1,000 meters. So multiplying this by 1,000 tells us that the tower is 553 meters high. We're starting 553 meters up, and from there we drop a penny. Look out below. So we know our displacement is going to be minus 553 because the coin went down. What else do we know? Well, Toronto is in Ontario, which is on Earth, so we know our acceleration, minus 9.81. Don't forget the negative, it's oriented down. Let's get our units right. And they use the magic word dropped. When something is dropped, that means you hold it still and then you let go. So its initial velocity should be 0. And they want VF. I'm debating doing this one. All right. Yeah, I'm going to do this one a different way just to give us a little variety here. First, I will say this formula, which we've seen quite a few times, will totally do the job here, but let's pretend that this formula is temporarily illegal and see if we can do this a different way. What else could we do here? We have this. VIT plus 1/2 AT squared. We could use this to find the fall time. And then from there we could get the final velocity. Let's see how that works for us. I'm going to have to create some space here. Whoa. I don't want to stretch it, I want to scoot it. There we go. All right, so our displacement is minus 553 equals VI was 0, wonderful, nice to see, times a time we don't know, plus 1/2 minus 9.81 times a time I don't know squared. That gives us minus 553 equals, the 0t is just 0, so we can forget about that. 1/2 times minus 9.81 is minus 4.905 t squared. If you want to get t squared alone, you divide both sides by 4.905. 553 divided by 4.905 is 112.7. So t squared is 112.7. And then if you square root that, you get t is 10.6 seconds. I was just talking about negative roots, and technically there is another possibility where t is minus 10.6 seconds, but that would be before we ever drop the coin. So don't think that's going to work. We need the positive time after we've released the coin and it's had some time to fall. So 10.6 seconds of drop. We'll put that up here. 10.6 seconds. And now that we have that, can we get a final velocity? Yes, yes we can. VF equals VI plus AT. Another great formula, which is not on your sheet in the form that I've given it. The way that they give it is they say acceleration or average acceleration is delta V over delta T. And what that means is the acceleration is the change in velocity, which is that, divided by the change in time. I'm not going to write TF minus TI. I'm just going to keep it as T for the elapsed time. We don't normally have to do the one with 2 times in it. And then if we multiply both sides by T, we get AT equals VF minus VI. And then we take the VI over to the other side, and we get VI plus AT equals VF. Great formula, use it a lot, and it will do the job for us here. So I'd say memorize this one, or at least get to where you can derive this really fast if you need it. It wants to be your friend. The final velocity we're looking for is our initial velocity of 0 plus our acceleration's minus 981, and our elapsed time is 10.6 seconds we just found. 10.6 times 9.81 is 103, pretty much 104. I guess this is our only given, and it had 3 digits in it, so yeah, we have to go to 104 meters per second. 104 meters per second, and because this was negative, the final velocity should be negative, because the coin will emphatically be going downward when it gets to this position.